Good morning, specialist class. Are you doing okay? I hope so. Today we're going to continue our quadrilateral proofs with example 4 on page 5. There's two parts to it. Part A, let's do that first. So part A says, prove that if opposite sides of a quadrilateral are equal in length, then it is a parallelogram. So first, let's start by drawing a diagram. So get out your trusty ruler because I do not want to see you free-handing your straight lines. You must be using a ruler to draw your straight lines. Using your ruler, let's draw a generic quadrilateral. That does not look good. Let me do that again. There we go. Quadrilateral. Let us label this quadrilateral. So let's go A, B, C, D. Just generic. What are we told? We're told that opposite sides are equal in length. So we're going to use our dashes to indicate that. So AB is the same length as CD. I'm going to indicate that with one dash, and that BD is the same length as AC. I'm going to indicate that with a dash as well. And our goal is to prove that it is a parallelogram. So let's write down our goal. So let's let A, B, C, D be any quadrilateral. So we're just defining our shape. Write down our goal, which is we want to prove that quadrilateral A, B, C, D is a parallelogram. Okay, now let's think. What are the characteristics of a parallelogram? Well, the characteristics of a parallelogram is that opposite sides are parallel. So we're thinking right now that we want to show, or we want to prove that AB is parallel to CD, and that AC is parallel to BD, because if opposite sides are parallel, then we've got a parallelogram. How do we prove parallel sides? Well, we always go back to our trusty congruent shapes. So far we've been dealing with congruent triangles. So if we can create some sort of triangles, then we've got a good start. So we're also thinking of, well, to prove parallel, we could use with some congruence, in particular congruent triangles. So to create a triangle, let's draw in a diagonal CB. So we're just going to create this line C to B. Make sure you use a trusty ruler to connect C to B in a beautiful straight line. Okay. So the goal is, if we can prove that angle AB, if I can prove that this angle and that angle are the same, then we can apply the reverse alternate angle to show that AB is parallel to CD. And similarly, if I can prove that AC is the same as that angle there, then using the alternate angle rule, or the reverse of it, we can show that the sides are parallel. So again, we're thinking, now that we've got triangles, we want to prove that angle ABC is the same as DCB, and angle ACB is the same as DBC. Then we can apply the reverse alternate angle rule. So that's our plan of attack. So we're going to prove congruent triangles. Once we prove congruent triangles, then we can prove that angle sizes are the same because of congruence. Because angle sizes are the same, we can then apply the alternate angle rule and prove that sides are parallel. And once sides are parallel, we get a parallelogram. So let CB be a diagonal of the quadrilateral ABCD, so that we can consider the triangle ABC and triangle DCB. So in our diagram, we're first going to look at ABC, yellow, versus the DCB, the blue triangle. So again, so this time, I'm not given any information about angles because I'm trying to prove that. I'm not given, so I can't use the SAS or AAS because I'm not given information about angles. I can't use RHS because I'm not given any right angles. So the only way I can prove congruence this time is by side, side, side. So if I can show that all three sides are the same, which is easy because our instruction is that we're told that the sides are equal in length, the opposite sides are. So that's easy to show that the triangles are congruent. Okay, so let's write that down. So from the diagram, CB is the common side because that's the diagonal we drew in. So CB is a common side. We know that AB is the same as DC because we're told that opposite sides are equal in length. So AB is equal to DC because that's given to us. We also know that AC, remember, match up your vertices. A matches up to D and C matches up to B. So AC is the same as DB again because we're told that opposite sides have the same length. Okay, so because we've got three sides are the same, so therefore triangle ABC is congruent to triangle DCB. Very important, make sure you match up your vertices. So angle C matches up to angle B. And the reasoning for this congruence is side, side, side. So that tells us because it is a congruent triangle, our angles are the same size. So angle ABC is the same as angle DCB because of congruent triangles, and then hence because of reverse alternate angle rule, we have that AB is parallel to DC because we've got the alternate angle reasoning. And because we've got the two triangles are congruent, we can also make the claim that, so back onto next column, so also, we have that angle ACB is the same as angle DBC. So ACB is this angle there, that's the same as DBC because we showed that the two triangles are congruent. So therefore AC is parallel to DB because of the alternate angle rule. There we go. So therefore, since two opposite sides are parallel, therefore the quadrilateral ABCD is a parallelogram. So we finish off our proof by restating the statement we wanted to prove, which is therefore if opposite sides of a quadrilateral are equal in length, then it is a parallelogram. So with these quadrilateral proofs, start off with a diagram, make sure it's labeled, make sure you use a ruler to draw the straight lines, write down your goal, your wanted proofs, have a think about what tools you need to be, what steps you need to be able to prove what you want. Most likely, 99% of the time, you'll be using congruent triangles, and the alternate angle rule, or the co-interior of the and the F rule. Then you're just going to show the congruent triangles using whichever code is applicable. Show parallel sides. In this case, opposite sides parallel. Both opposite sides are parallel, meaning it's a parallelogram. So finally finish off with a statement which is restating what the original goal of your task was.